Assalamualaikum, a very good morning to all. So, are you ready? We have to our class today, so I hope that we can finish chapter 6 today. And for today's lesson is that we have few breakout sessions. And for this time around, because there are some comments from students that the breakout session might be because it's randomly picked. So for this time around, I'm going to give a student to choose their grouping. So, but there will be a limit group student number in one group. So basically, I will limit it to 5 members per group. So that is how we are going to do it. So it means that you need to join any group. And if you see that group, you want to be the member of that group, then you can join that, right? Okay, everybody can hear me? Because it's a bit silent. Okay, all right. All right. Okay, so we are going to start the class for today. So before that, as usual, please go to Yulen and make sure that you have taken the attendance for week 8. Okay. And yesterday I did announcement in the group, Telegram group about midterm exam. So here I would like to confirm with students. Okay, tentatively I have discussed with PM Dr. Fahmi. So we are going to do the midterm exam on 16 December on Thursday. So is everyone okay with that date?
Okay, Doctor.
Okay, alright. So the time is at night. So don't switch up. Okay. Sometimes student give excuses that the wrong time. But anyway, the time is at night. So 9 p.m. To 10 p.m. It's about 1 hour. So question type will be MCQ type. MCQ type is multiple choice question. So basically what you have done, you're given, I think Dr. Fahmi, himself and myself, we have given students MCQ type question for each topic. So basically it will be not similar question, okay, but the knowledge that you have learned throughout the lessons from topic 1 to chapter 1 to chapter 4 will be asked in the MCQ question. Okay, so maybe some question will be like multiple answer. Okay, and some are being matched and so on. Right. So as long as you study for the midterm exam, then I think I'm sure you can answer the question. And FYI, the question will be shuffled, so not all students will not be getting the same question. Okay, so that will be all. And of course, because it's online exam, so it's open book. So basically, my suggestion is that student need to download. Make sure that you download all the notes that I have uploaded in Ulearn. Download it and then put in your own folder in your computer so that you can refer it anytime. Okay, if you are going to actually click the Ulearn at that time, and it will take time to open the PDF and so on. If your computer is lagging, then you will take time to actually open something. So it's best to actually print out, for example, print out the notes given. Okay, that's the reason why I ask students to download and make sure that you print out, because at the side there you see that there's an empty spaces for you to jot down. So while you are listening to me online, you can jot down directly. It will be the same method if I'm teaching you face to face in class. In class, I'm really a bit constrict lah. I really like student to actually focus in class, and by focusing, it's not only focusing to the lecturer talking in front, but they take note. Okay, so my notes is most of the time it's not complete note. Okay, so they need to fill in the blanks and so on. Okay. So, and for the midterm exam, we will be doing it in my Ulearn, this Ulearn. So basically, PM Dr. Fahmi student also will be joining this Ulearn. And how you answer is that by clicking this tab, and then the question will be inside here, this part lah. Okay, so right now I think for my student should be no problem. I seen that all 32 students already registered, so I have 32 students according to the registration. So should be okay. And for Dr. Fahmi, only 19. I think Dr. Fahmi's student is about 40 something. So if you know any section 1 student, please inform them to quickly or join my ULearn and then click the grouping. Reason why grouping is that later when you answer for the midterm, student in that group only can answer, can log in to that question. So by grouping, so easier for us to actually analyze the marks later on. Okay, if not, we are going to sort it manually and it will become a bit complicated for the lecturer to evaluate the result later on. Okay, so that's on the midterm exam. So so because no one say that there's anything clash and so on, so we are going to fix it at 16 December. And then okay, yesterday feedback. Okay, thank you for all students. I think almost everybody answered the feedback. 30 students 30 students, so ada 2 more students didn't fill in up, so please make sure to fill that up. Okay, I will just go into the last question, which is on which part you don't understand. Okay, so far I think 1 student only needs some extra additional explanation on that topic. Okay, so the question is on related to rotary to translational. Okay, so let me just open the slide. Yes. Okay, so the question was on on the, okay, just a recap. Okay, recap a bit on yesterday. Yesterday is that you learn there are two pure motion, which is on rotational, okay, and also translational. So basically rotational means that rotation is going to rotate 360 degrees and so on. Translational means that linear motion. It can be moving in X direction, Y direction, or Z direction. Okay, so in only one direction. And based on the pure rotation, you can actually convert some motion, okay, in between using mechanism from rotary to rotary, translational to translational, rotary to translational, and translational to rotary. So the question was on a type of motion from rotation to translational. Okay, so basically it's almost the same between translational to rotary. Okay, so it can actually be swiped up. Okay, so means that when we talk about transferring from rotary motion, means that the first part that you're going to connect to a motor, for example, if you have a motor at this end, motor, so you're going to connect the part that motor to a rotation mechanism. So for example, a gear mechanism. So we talk about this type of gear lah, okay, in the rack and pinion mechanism. So gear mechanism. And then because we want to convert that rotary motion, this is going to move in rotation. Okay, clockwise or counterclockwise depending on the motor signal, okay, the drive of the motor. Okay, so based on that, it's going to rotate. So imagine that the gear is going to rotate, and based on that, this pinion, okay, is the rack will be moving, sliding in the X direction. Okay, so it's going to rotate and sliding along. Okay, so this is where you have so imagine that there's the gear and it's going to slide like this way lah. Okay, and another way that you can use this rotation to translation is that lead screw mechanism. Okay, lead screw mechanism. So let me just click this one because it's okay. So if you see this type of, this is an example of a lead screw mechanism. So at the end here is connected to, oh cepat sangat, is connected to a motor. Okay, and then when a motor rotates, this end here is going to connect to a table which is going to rotate to move along that screw. Okay, so it's going to rotate and move it. So that's where you can actually convert from rotary to linear. Linear means that this part, okay, this part, shaft, or not shaft, this end part, which is the screw, the lead part, will be connected to a table, and that table will be moving. Okay, maybe this one is just the concept of mechanism. Okay, so let's look at the 3D printer. Okay, example of where you can apply it in real life application. Let me just share that with sound. Okay, share. Right. So you see, this one is a 3D printer. This one is a 3D printer. It's printing. If you have seen a 3D printer before, it's exactly like a printer. Just that when 3D print, you can print a 3D object lah. Okay. So what happened is that underneath here, if you see here, down here, is a table. The table is moving X, Y, X, Y, X, Y. Okay. And sometimes it's going to move up Z direction. But right now, it's actually printing in the XY direction. Okay. So, you see here, down here, okay, there's a motor rotating. Motor rotating. And that is, motor is connected to a lead screw. The one that I showed you the first video. Okay. That lead screw is going to convert that rotation. Motor is converting that rotation to this stable motion, which is moving XY, XY, XX, or YY. Alright? So, it's not going to rotate. The table, you do not see that the table is rotating. Okay? It's only moving in planar motion. Planar motion means that XY planar motion. Right? So, this one is, so basically, if you see here, this 3D printer, it has 3 motor and 3 lead screw. Okay, where is it? This one is the first one. The second one is on top here. It's actually, this is motor connected to a lead screw. And that lead screw, the one that I showed you, the part here is connected to this extruder. So the extruder is moving left, right. Okay, this one is only controlling the left, right motion. The lead screw down here is controlling the Y motion. Okay, another lead screw is on top here. If you see here, this is another lead screw. It's controlling the Z
One of the great
direction.
challenges in
Okay, so I hope that answer on the concept of conversion between rotary to translational. Okay, so clear? I think siapa tanya hari tu? Clear on that question? Okay, this one. Oh, and by the way, okay, thank you. I really appreciate for student who actually wrote up a very uh who wrote up a detailed feedback on the class. Okay, example, because I really appreciate a student to give feedback on what is the contents, delivery, and so on. So example like this one, quite a long explanation. Well, like Tio, okay, very long explanation. So I know that when you explain everything, you explain about what you learn in topic of 1 hour. So you actually will understand the topic. So like for example, those who are answering short answer. Okay, I hope that you still understand but if you do not understand, then please make sure macam ni, I'm not sure, Nur Shifa, maybe you didn't write it full, so don't do this. Okay, so oh well, there is one question from the student. Okay, discuss final exam. Okay, FYI, I normally do not give um apa tips for final exam, but we will discuss the example of final exam, past year final exam later. Okay, I'm not going to discuss it now at the beginning of the class because you need to know the concept first. Okay, like example, concept of mechanism. If I just throw you the example of final exam, then you cannot answer it. Okay, so you need to know everything about mechanism, then only I can share you the question and we discuss it. Okay, I'm not going to give you the answer for the final exam. You are going to discuss it in the group later on. So that's where we will have later, because we have ample time to actually have several group discussion for final exam discussion. So don't worry, we are going to discuss that, but in a group, and you will actually practice on how to answer it, because final exam, it's not going to be the same question. It will be on application. Okay. The question is not direct, so you need to know a lot of application of mechatronic system to answer the final exam later on. Okay, so there's no one answer to fit all. Okay, so okay, Divin was asking the question. So did you did my explanation is my explanation clear? Is Divin here? Divin is here. Okay, so I hope you understand. Okay, so now let's go to the continuity of yesterday class. So I hope you have already looked at this video. So you can also look at example of other type of mechanism. Yesterday I showed to you one YouTuber link is on designing SolidWorks. So let me just look at example of rotary to linear. Okay. Because there's a lot so let me just skim through it.
KitKat Bar baharu, lebih coklat, lebih
This is not it screw. Okay, I cannot find it, but anyway, you can just type there lead screw lead screw stepper motor example. Okay, okay, this one. Actually, this type of system normally I will share to you in the control part subject, the application. But well, because you asked, so okay, example, this is motor. Okay, connected to the lead screw, so this table will be moving. It's the same concept of 3D printer just now. Okay, so let's just start with the slide. Okay, so this is just a summary. You can read through yourself. So summary of the kinematic chain, the characteristic, the came and follower, gear, ratchet and pawl. Okay, and most of the time, if that later we will go through all of this in detail one by one. So ratchet and pawl is normally we will use it for locking mechanism. Okay, so ratchet point is normally, if you have seen a cutter for not aluminium, for plastic tubing, okay, you want to cut that. So you want to cut it, you are going to use the ratchet point because it will be a locking mechanism, so it's easy for you to cut compared to you if you use a normal scissors. And you have learned also on belt and drive chain and bearings later on. Okay, so let's just directly go to the types of linkages. But before we go to linkages, I want to share a bit on what are the degree of freedom. Okay, so that you know the concept. So degree of freedom is determined by the number of components of motion that are required in order to generate motion. Okay, so it means that it can be 1 DOF. So 1 DOF means that you have only motion in one direction, okay, in x-axis only. Okay, so it can be also have, and for this case is that is in translational motion. Okay, example shown in this figure. And another example of 2D OF that you can see is example of this motion. So you have the translational motion, and then you have also this one can actually move in rotation. So this one also means you have two number of DOF. Okay, means that degree of motion. And most of the time you will see people talking about DOF in robotics. So normally they say that 6 DOF robotic arm and so on. So means that the arm can actually move in 6 links. So it can be like our human hand. So the link here, this link, okay, not only this way, but we can actually twist it like this. So it's also can actually rotate. So our risk is most of the time is more than it's 3 DOF, because it can actually rotate and also do a translation motion. Okay, so with that we go to linkages. So in linkages is that we are going to talk about when we talk about linkages just now, we know that we have joints there. Joints is where it's going to be have a fixed point, so fixed point here. And also we have the link. Okay, link. So there are two concepts lah. We have the joint and link. And for the linkages, as example, if you see here is the crank and slider mechanism. Okay, so I hope that student already view the video, the Telegram group video, and also in the Padlet, I have shared a video on the engine mechanism. So one of the item that we have in the engine block is actually we call it as the, if the mechanism full name is crank and slider mechanism. Okay, crank and slider mechanism. So which one is the crank? Crank is this part. Okay, this part. Okay, so the part which is a joint is the one is fixed point. So we have the first joint, second joint, and third joint. Okay, so this one is going to be rotating, and this one is going to push up this piston. Okay, we call this as the piston. So basically the piston is actually the slider lah, because the piston is going to move up and down depending on the crank here motion. So crankshaft is actually, okay, in an engine block, you have actually a few crank. You have a few, we call it as the cylinder. Okay, so normally 4 cylinder. Okay, and then you have the crankshaft beneath here, and that crankshaft is all connected, okay, using a crankshaft. Okay, so this is crankshaft is the shaft lah. Shaft tu batang. So it's going to connect all of the shaft together. So the crankshaft is going to be rotating. So when it rotates, it's going to move the piston up and down inside here. Okay, so it has a sequence lah. So if you have seen the video, you will know the next question in the palette is that you need to discuss what are the stages in a engine block mechanism. Okay, and on top of here, later on, we will look at one of the mechanism that we have in the engine block, which is cam and follower. Cam and follower, but it's not here, because this is only on linkages. So, but in most of the engine block, we have two main mechanism that you can see, which is the crank and slider, and also cam and follower. Right. So let me just oh, not this one. This is the link. Mana pergi? I think it goes here. Okay.
Berlari maraton?
Banyak betul iklan Okay. So look at this one this video what do you think? Is it a human? What type of mechanism is used? Linkages Okay, thank you, Nick. So yeah, the mechanism that it's using for this, they call it as a strand beast evolution 2017. So if you see here, the how they call it as a beast because it's moving even though it's not a living thing so it's actually move depending on the wind. Okay, wind as the input lah. So based on that, the wind is going to actually move all the linkages, and the beast, they call it as the beast, is going to move due to the linkages. So the perfectly we call it as perfectly designed linkages will actually move a structure. Okay, for example, this structure is very large, but because it's actually linked very well, so it can actually move without any power except for wind power. Okay, so you can look at this video. It's in the link in the YouTube, and also this is the homepage of the strand base so it's really interesting if you want to look at the video. So they you can see that evolution even the for the strand base, they have the evolution since 1989. So you can see that how he designed it from zero and then go up to the latest one is in 2021. Okay, so it's quite interesting to actually look at that video because it's related to the linkages part. Okay, so if you see linkages, just as mentioned just now for the 2DF, is that each part of the mechanism has motion relative to some other parts in terms of link. Okay, so the link, this one is the link lah or connector. So we have the link here. Okay, and the circle part is the joint. So basically, it's going to be connected to each other, and the rigid body has two or more points attached to other link. So determine the node. So that node is actually the joint. Okay. So when it moves, it can actually move to relative link to other link. So most of the time, one of the link will be connected to a motor or to a pneumatic actuator or to a hydraulic actuator because it will give motion. But for the example of the strand base just now, the input is the wind. The wind is going to give the motion, okay, initial motion. So that is going to be a continuous motion. If you have wind, then it's going to be continuous movement. So example of linkages, okay, are levers, crank, just now, crank and slider, connecting rod and pistons, example in the engine block just now, okay, pulley, belts, most of that are linkages. So normally you don't actually use only sliders or crank alone. All of these are connected to linkages. So okay, for the main thing that you need to know for linkages are two main basic kinematic chains, okay, which is the 4-bar link and slider crank chain or slider crank mechanism. So slider crank mechanism is this one, this engine block. 4-bar link is something that you will see later on in the next slide, is this one, okay, 4-bar link. So 4-bar link, normally as what it mentioned, you have a 4 link, 4 link connected to give 4 joints above which turning can occur, means that it will give a rotation. Okay, so before we go to the 4-bar link, let's just go to the slider crank mechanism. So a bit on the engine control system. If you have seen in the video, maybe the video is just taking the real application. So, but when we talk about engine control system, is that it has the hydraulic system. Okay, hydraulic system most of the time, because you know that hydraulic system is going to put pressure. When you need pressure to pressurize something, it's either you need to have a hydraulic system or a pneumatic system. So for the case of vehicle, you normally have a hydraulic system. That's why you need to top up the hydraulic liquid and so on in your engine block. So reason why you have that hydraulic system is that for the combustion inside to happen. Okay, so if you watch the video on engine, a combustion engine, what happened is that you have here the circle part is you have two parts. First one is this will be the crankshaft mechanism. So, okay, this one is crank and slider mechanism. And at this part, top part here will be the cam and follower. Alright, so how does it work? Okay, before we go to this, okay, and the next slide, let's go to a breakup session first. Okay, in the breakup session, what you're going to do is to look at this, to complete this task. Okay, so there are two questions that you need to do. Okay, only these two only. Okay, watch and answer the question. So basically down here, I think Syafiq dah answer, but anyway, we will discuss that in a group. Tak apa Syafiq, tak apa, biarkan saja kat situ. But what you need to do is that watch this video down here. The question is inside there. So there are two questions.
I'm Jake O'Neill.
Oh, sorry. There are two questions down there. I cannot see the question. What's the question?
I'm Jake O'Neill, creator of Animagraphs, and this is how a car engine works.
Oh my.
Let's start at a single piston, the powerhouse of the engine, and work our way outwards.
Where did the question go? Okay, I think is it deleted? Okay. Who clicked the video just now? Can you give me the link? I cannot remember what link I give to you guys. Anyone? Click on the video just now? Oh, Syafiq? Ada click tak? Can you give me the chat in the chat there? The link just now. I think I deleted and it cannot actually revert back.
Alamak. Saya pun
Anyone?
tak ada buka
Memanglah dah deleted. Anyone actually click the link?
Ya, tengok balik. Tekan.
Delicious Nutella and puffed wheat Krispies in a crunchy shell.
Oh, this one Oh, okay, this one. Okay. Alright. The question is, let me just paste again the question. Sorry for that. This is what happened when we have online class. Salah tekan je delete. Lepas tu
Soalan
tak
yang
boleh
first
undo
tu
pula.
list
Soalan
for
first dia
type
apa?
of stroke. List for of stroke.
List for types of stroke, is strokes
In engine block.
in engine block. Soalan kedua.
List all mechanism in a engine.
Okay, thank you. Okay, so ini soalan dia. Terbaik ada seorang nak buat. Okay, so that's a question. Okay, you need to answer two questions, which is this one. and another one is this one. Okay, so maybe it looks similar, but in this question is that the mechanism is much more detailed. It's other than the component in this video. So watch both video. Okay, watch both video, and then you are going to discuss in a group. But in the breakout session is that you can choose your own group. Okay, but maximum 5. After 5, then after when it complete 5 members, then you cannot enter anymore lah. So join the one that is empty. So I will give you roughly about maybe 30 minutes. Okay, so that 30 minutes mean that you have very ample time lah to discuss 30 minutes on that. And if you find that, okay, even though we have only go up to linkages, but yesterday I have explained a lot on the mechanism. So try to find out what type of mechanism there is in these 2 video. Okay, yang last one tu tak perlu lagi. Yang these 2 question only. Okay, so we will start now, and while we do that, you can take a break and so on lah. So it's 30 minutes. Belum lagi. Saya belum enable lagi. Kejap. Sabar. Okay. So, 5 orang. Tak sabar ni. Kejap. Mana saya punya calculator? Saya belum set lagi. Kejap. Sekarang ni ada berapa orang dalam ni? 34. So, 32 bahagi dengan 5. Oh, sorry. So, lebih kurang 6 lah. 6 orang. 5 ke 6 orang. So, saya letak situ number of breakout session 5 lah kot. 5 lebih kurang 5 session. 6 session So there are some group ada 5 student, ada 6 So you can choose your own So sekejap, assign participant manually, let participant choose any session. Alright, we will start now So we will stop at 10 automatically in breakout session. Okay, we start now. You can join, click on any breakout session. So maybe one student join first lah kot. Okay, yang lain boleh masuk lah. Ikutlah yang mana yang you nak Nampak kawan kan? Ada nama kawan tu, masuk. Jangan keluar masuk Macam mana kawan nak pilih tu. Okay, klik. Boleh? Masuk. Yang lain, please klik. Susah kalau nak kena pilih sendiri. Baik, saya automatically assign. Okay. Andrew, Chen, Iqbal, Nur Shifa, Nur Rafika, Najwa, Suh, Tai, Tio. Please click any group to join It's not automatic.
Where to click? Where to
click? On, I think it's on the right side. You need to open, I think there's a breakout session on the right side there. You're using handphone, is it?
No.
No. So on the top there, I think when I assign breakout session just now, it should be, try to click participant. Is there any breakout session opening?
Okay, I see. Thank you,
Okay,
Doctor.
so click there. Okay, any group.
Okay.
Maximum according to the number inside there. Zuhari, boleh tak tekan pada participant if you're using PC.
Boleh.
Boleh. Sekejap, I tengok. Kalau guna handphone, you tekan participant. Kalau guna handphone tekan participant ke atas ni. Shifa, I'm not sure if you are using handphone. Kalau handphone tekan participant, then you tengah tengok akan ada banyak show all session lah. So masuklah session mana yang you nak. Shifa?
Kejap doktor, ibu saya lag.
Oh. You guna handphone ke you guna laptop?
Pun.
Okay. You pergi, nampak tadi? You tekan participant ke atas tu. Participant. Kejap saya tunjukkan. Saya boleh tunjukkan ke kat sini? Okay, you tekan participant ke atas ni. Okay, ada muka orang kan. Lepas tu show all session. Okay, nanti ada nampak lah breakout session 1 ada 4. Daripada 4 boleh join lagi tu. Tekan join. Okay. Kat bawah tu ada banyak lagi session, contoh breakout session 4. Boleh masuk. Okay, ada 2 orang aja baru. So boleh masuk lah.
This is a ratcheting PVC.
guys. Okay, you are back. So, have you completed? I think in the Padlet there's no update, eh? So, is it difficult, the task? No, right? If you have watched the video, have you completed it? 4 types of stroke.
Dah. Sekejap nak
Uh,
upload.
okay. This upload. I think 30 minutes is ample. The video is only about 4 minutes. Then another video is about, I think, roughly about that time. Okay, name the group. The submission as group number. So if you were in the group breakout session 1, then it's group 1. And then write down your team members lah. Okay, the name of the members just now. Okay, I will call out students' name to actually to elaborate the answer. So example for this tab, okay, what is the full stroke, and then list of mechanism that you can see in the video. And also for another video, what that you can see. Okay, when I talk about mechanism, means that mechanism, not including hydraulic actuator, pneumatic actuator. No, only mechanism. So you need to differentiate what are the mechanism inside. Okay. So it shouldn't be a very long answer. It should be very short one, just point form. A tip for student when we are in this Padlet. Okay, easiest way to upload something in Padlet is that open your Word file, type everything in your Word file, and then for example the group name lah, tadi group 6 ke apa kan. So type in the Word, copy, Control C, Control V in a Padlet. So it will be very easy lah, other than you type in the Padlet kan scrunchy small spaces. So kena be efficient lah. Okay, there are lots of application that you can use to actually type out, then you just transfer it. Okay, and you can actually save it in a file and save that as a task or lesson for week 8. Okay, so be productive and be efficient when you take notes. And I would suggest that student, okay, while we wait because we are still waiting for student to update.
Betul nak tanya.
Sharing. Okay, boleh?
Kalau macam oil pump, oil fan, oil filter kan, dia kira mekanism juga ke?
No, that one is a part of hydraulic system.
Oh, tu kira hydraulic
Yeah. Oil pump kan, pump, compression semua tu kan. Pump when talk about pump is hydraulic or pneumatic. So that is a part of the hydraulic system. Mechanism is the one that I shared you basically in the slide. If you see in the slide, original slide, okay, mechanism is mostly consists of this part only. You don't see any I didn't mention anything about pump or anything. Okay, mechanism is comprised of, it's either this one, rotation to rotational. So this is our mechanism for rotation to rotational. Translation to translational, all mechanism. Rotational to translational is this one. Okay, so basically it's mechanical part. Okay, it doesn't have the pump or compressor. That one we talk in the previous chapter, in chapter hydraulic and pneumatic. Okay, it's a system comprised of compressor, filtering, and so on. So it's not mechanism. Okay, so I hope that you are clear. Siapa tadi Syafiq
Happy.
Okay, Syafiq So I hope you are clear. But the video that I shared to you in Padlet is important for you to understand is when we talk about actuator, mechanism, pneumatic, hydraulic, electrical, it's not standalone. In any application, it's a combined mechanism. A combined system lah. So you have either, for example, in the block engine just now, when you watch the video, you may see that you might get confused on this one is mechanism or this one is hydraulic. Okay, so we have a part of the hydraulic in engine block, which is where you need the compression of the air to be compressed inside that combustion system. So you need the hydraulic system to compress air. And you don't have a compressor, basically, a compressor or pneumatic system in a car. Okay, it's very it's dangerous basically if you have a pneumatic system in a car. So that's why you have hydraulic, easier to maintain because you need to just top up the oil. Okay, so there is a combination. You need to have a hydraulic. You need to have, of course, when you talk about mechanical converting motion to motion, then you need to have mechanism inside a car. And then right now we have hybrid car or full electric car like Tesla and so on. So you have electrical part. So you dah combine the whole thing. So Tesla is a very good example of mechatronic system lah, basically, because it combine all of the element of actuator. Okay, measurement system, it has sensor. Okay, it has data presentation. Basically, you see that in the console, you can see everything. Okay, you can see the sensor being detected and so on. Okay, and then you have the signal conditioning because you're converting from physical motion to electrical motion and vice versa. So you need to actually convert from analog to digital. So lots of that component in Tesla inside that. But later in the chapter, now it's chapter 6, chapter 8 chapter 8, we will go to the last part, which is on control system in mechatronics. So I will give you an example of Tesla lah, basically Tesla. So we're not talking right now. Okay, we are on mechanism, so we focus on mechanism first. Okay, so I just want to share just now. Still waiting for the student to update. Okay, okay, let me just show to you example. Okay, I think most of you have your own computer. Okay, you have your own computer, and I'm not sure how you actually manage your file in your computer. But for me, I make it systematic. So, for me to make it systematic, you need to do a numbering. Okay, so I can see that I have taught a lot of semester. So this one is continuing from another computer. So right now we are at this part. Okay, so you can see that under each semester also there are a few topic example. Okay, let's look at this semester. So this semester I have the agihan beban tugas and jadual, the schedule. For this semester I have the subject advancement of teaching. I am also teaching industrial robotics. Okay. So you can actually manage your own folder in your computer. Be systematic so that it's easier for you to find it. So for your case as a student, I would suggest that in your computer, in your drive D, kan, you have a folder according to semester. And in that semester, you have a folder according to subject. Okay, so it will be easier for you to call back all the notes. Okay, the notes that the lecturer shared to you, you can put it in a folder. So example like this subject. In the subject, I have the notes, tutorial, I have the industrial visit, planning, and so on. So do that, be systematic so that easier for you to get to actually refer back later. So example notes kan, you have chapter 1, 2, 3 and so on. So do that. So be systematic. As a student, you need to learn now because when you are working later on, you need to do this. Okay, you cannot just dump every file in one drive D. Okay, because I have seen a lot of not only student but staff. The folder is chaotic and it's impossible for you to find document later on. Okay, takkan you nak find document by searching the name the file of the name. Okay, so it will be kind of impossible. Okay, let's say I give you one more example. Right now I'm at the KAIS, a training center for UTEM. So if you see I did a numbering so that easy for me to know which folder is the latest. So let's say I have a meeting, lots of meeting here. So the meeting or the folder of that meeting, I will number it according to the date. Okay, so I know basically, if I didn't number the folder according to date, then basically I won't know, mesyuarat pemekasaan BI staff academic. So when did that happen? Was it in 2019? Was it in 2021? I do not know. So how I number the folder is according to date, and if you see here, the date is terbalik. Okay, I follow Japanese style because I actually study in Japan last time. So the Japan, how they write the date is year first, year, month, and date. And you will see that it's easier to follow that style. Reason why? It will actually organize according to the year. If you write that according to date, it will mix together. Okay, if you see, let's say that it's 31, for example, 01 if I were to take the top date, and 2021. Okay, this is the first folder. Okay, if I follow date first. And then just down there is meeting pejabat TNCA 11/6/2021. Okay, so do you see how the folder is being arranged? Okay, so it's being arranged by the date, and which is in the end, I want to see what year. So basically, it's very hard for me to detect which year is it. Okay, so that's the reason why sometimes people may find it weird. Why I edit a file folder according to date, but the reason why for me to search easier in a folder. So take that as a tip. So that later you can be really systematic, find any document. Okay, people ask you any document, you can give them in a blink of an eye because you know where it is. Okay, so everybody updated. Okay, so if everybody updated the answer, so let me call one person to answer for this first video. Okay, Muhammad Iqbal Zabidi. Muhammad
Yes,
Iqbal
doctor.
dia. Okay, can you share the screen? Show your answer. I mean your group answer lah.
Wait.
Okay. Muhammad Zabidi group mana? Muhammad Zabidi pula. Muhammad Iqbal lah tadi. Sorry saya for some reason saya ingat nama bapa. Nama bapa Okay, Muhammad Iqbal Zabidi Okay, grup ramai orang ni, grup 6. Mana? Iqbal? Mana awak pergi? Okay, tak apalah saya sharekan screen. Iqbal bercakap je, boleh? Iqbal? Iqbal? Mana pula dia pergi? Iqbal ada tak? Dah tak ada Iqbalnya. Okay, Iqbal tak ada. Dah terkeluar kot. Okay, tak apa. Group member lah macam tu. Group member. Siapa group member? Sekejap Group member. Syafiq tak perlu. Dah banyak kali jawab. Sekejap. Chiu Zihao. Chiu pun dah, sorry. Okay, Tan Shini pun dah pernah jawab. Nur Arifah. Okay, Nur Arifah. Nur Arifah. Nur Arifah ada tak? Arifah. Arifah ada? Arifah?
Tanda jap. Sakit perut.
Siapa tu?
Saya, Syafiq.
Yang bagi tanda sini siapa?
Arifah.
Oh. Iqbal dah masuk balik. Iqbal, tak dengar. Tengah bercakap ke?
Saya.
Okay, saya tunjukkan screen, you explain. Okay? Iqbal, you explain.
Yang first ni, ni jadi waktu macam terus dia akan pusing bawah tu, lepas tu piston dia akan turun.
Apa dia? Soalan dia tadi berapa? How many stroke in engine block?
Dia first stroke in the block.
Explain lah. Okay, macam ni for student when we do breakout session and after that I ask student to explain. When I ask student to explain, is basically like what you have seen me explaining slide So everything is in the slide, but you need to elaborate and explain. Okay, so reason why first is to brush up or to practice communication skill. Okay, so kalau you tak practice dalam kelas, where are you going to practice? Speaking or talking to an audience. So this is the best platform to actually speak. Okay, you don't want to speak later in an interview and then explain a bit about yourself, and then you blank. You are not used to explain. And then you say, is everything in my CV? That's not good way to introduce yourself. Yeah. So, don't be shy lah. Basically, in my class, and I prefer English. Explain it in English. Reason why? Practice English from now. If you are not used to English, you need to practice now because later when you start working, everything need to interview in English. Jarang lah berlaku interview dalam bahasa Melayu. Okay, so no matter what, you still need to brush up your English. You cannot say, nantilah saya belajar English. You nak belajar bila? Okay, the best way to improve communication is practice now in class. Okay, so back again to Iqbal. Boleh try slow-slow lah. Slow-slow. Okay.
Dia kata, apostrophe terus intake. Intake
What happened during the intake? Intake stroke. I'm not clear. Okay, anyone who want to help? Okay, basically, even though there's a list what are the 4 stroke, but when you want to explain, I would suggest that explain full. During the intake stroke, the crank shaft will rotate and it will pull down the piston. Okay, piston will move downward and will the oxygen and also oil intake will enter the chamber. Okay, first intake stroke. Okay, that is how you explain what's happening during the intake. Okay, whatever you hear during when you watch the video, you should be able to repeat it. Okay, repeat aja. Saya bukannya suruh you translate to bahasa Melayu pun. As long as you're able to explain again what they explain in the YouTube, then I know you understand it. The reason why I do this discussion is that kenapa sebab I know some student when after class they don't actually look back the task given to top, then they enter for midterm and final exam without doing any planning, okay, any revision. So when we go for exam, you need to explain, elaborate to get high marks, to get more marks. It need to be a detailed explanation. Okay, you bukan boleh simply copy paste je daripada you punya textbook. Okay, we can actually, lecturer can detect okay, this is tip for final exam because ada student tanya macam mana tips untuk final exam. So lecturer can detect student taking directly from book or they understood the content itself, the principle, the application. So the how student explain, we know that student understood the question and they can answer it. Okay, so try to be at that level. Okay, where you can able to explain again. You have a diagram right now. You're able to explain the intake stroke, compression stroke, power stroke, and exhaust stroke. So what happened during that 4 intake? Okay. Gambar dah cantik. Okay, gambar saya bagi A+. Gambar siapa? Yang buat ni memang cantik. Okay, but explanation it's a bit so-so lah. Kalau orang Japanese cakap so-so. tak berapa nak clear Okay, so mungkin Nick yang lukis, can we invite Nick to explain? Cepat, saya nak at least one student full explanation of this. Boleh bantu Iqbal, okay? Nick?
Kalau tengok yang pertama tu intake kan. Intake tu dia yang pertama tu air dengan gas campuran yang daripada minyak dan udara dia akan masuk. Dan intake valve tu akan terbuka. Lepas tu kedua tu compression tu dia akan pedap benda tu. Gas dan air.
Pedap. Okay, dia pekat ni. Bahasa apa ni? Okay. Okay, the second compression, okay, I translate for Nick, is what happens that the crank will rotate and it's going to push the slider up. It's going to compress the air and oil. Okay, so it's going to compress. This is where you will have a combustion. Okay, so and both valve is closed. So air dengan fuel tadi tak boleh keluar. Okay, next Nick. Third.
Yang third tu about power, yang apa tu spark plug will pecikkan api, sedikit api untuk bakar bahan bakar tu, air dan gas tu untuk hasilkan power. So the piston will go down
Mm-hmm.
and crankshaft will rotate. And
Okay.
then yang 4 tu exhaust. Exhaust
Uh-huh.
tu
Mm-hmm.
after dia burning the apa tu bahan bakar tu, valve exhaust akan terbuka, akan keluarkan udara carbon dioksida tu.
Alright, great. Okay, great, good explanation. So normally I know, okay, whoever draw this, he or she can explain it. Okay, normally lah. Siapa yang tak lukis dia tak tahu nak explain apa basically. Okay, so good job, Nick. Okay, next question is that what type of mechanism that you can find in the engine block? So, I ask Nadi group. Mana pergi dia? Okay, group mana ni? Lin Hong Lim. Tadi Nik Syarul
Ya saya, Nik Syarul Fahmi.
Okay. Lin ada? Lin Hong Lim. Lin? Lin? Lin. Lin? Yeah. Lin, hello. Are you there? Or sleeping? Can you hear me? No, I cannot hear you, Lin. Kejap. I try to... No, I cannot hear you. Okay. In your setting there, okay. Okay. Are you talking?
Hello?
Yeah. Okay, now I can hear you.
Okay.
Okay. Alright, Lin. Sekejap, I
Yes,
open. Lin. Okay, Lin, explain the mechanism.
Okay. There are 1, 2, 3, 4, 5 mechanisms in the engines, which are the camshaft, the cam gears, timing belts, and crankshaft and flywheel. The flywheel is basically the gear mechanism in the engines, which the starter will spin the flywheel and the engine will start doing its works. And then the crankshaft is linked to the piston, which it is a linkage mechanism that will push the piston in a linear motions up and down.
Okay.
And the timing belt is used to rotate the cam rods on the heads of the engines when the crankshaft is spinning.
Okay.
So when the crankshaft is rotate, the cams and followers will also rotate together using the timing belt. The cam the cam and followers is used to control the
Movement.
up and down movement of the invalve.
Okay. The two valve Okay.
Yes. the
Inlet
two
and
valve.
output valve Exhaust valve
Yes.
Okay.
Yeah.
Alright. Explanation is good. Okay. If I were you, I were to give marks Okay. But basically the question like this is not going to come up in your final exam lah. The question would be like something like, oh, you need to explain like just now. And like example, list, you're given a diagram. Okay, list what are the mechanism and description of each mechanism. Okay, so I like how the way Lynn explained just now. Means that you explain each of the component in detail. And I think the best way, if you can, is you have a diagram to explain it. It doesn't mean that you need to draw the diagram because right now you are online exam kan. So you can just take a diagram from internet and then label it and then explain each of it. Okay, so not copy paste the text, but just take the diagram to explain it. Okay, so that is how you can get full marks. okay, in exam. So example in past year question, we are going to give you case study of some different application. So students are going to solve the problem, okay, by suggesting what type of actuator, what type of mechanism need to be used in that type of system, okay, what type of sensor and so on. So different student, different answer, okay. And this one is just a reminder to students, okay. Uh, some student ada yang meniru during final exam last time, and we detect meniru, even though the question we have more than 10 sets of question. Okay, meniru means that basically drawing is 100% similar. Okay, explanation is also similar, so both get 0 mark for that question. So take note that please avoid copying from each other. Okay, you need to come up with your own idea. If you're found cheating, siapa yang bagi meniru dan siapa yang meniru dulu dapat kosong. Okay, so this one is a reminder for all students. So good. Lynn, okay, thank you. So
Thank you, madam.
alright. So next, okay, that one is the one video. Okay, timing of. The second video is almost similar, but with additional of timing back and chain sebenarnya. Addition of that. Okay, so you can see that in that video, other than the combustion engine itself, you have also the addition of bring back the overall view of the engine block. So based on that, then I can explain this. Okay, so you have seen all the component in an engine block. Okay. Okay, so basically what your friend was explaining just now is that we have the crank and slider in this part. Okay, this is slider. Okay, is in the upward position. So the slider can actually move up and down, and the crank is actually rotating. So based on that, the slider can compress and depress air accordingly. Okay, so it need to be sequential. Okay, and the valve on top of here. Okay, there are two valves. One is inlet valve and one is exhaust valve. Similar like pneumatic and hydraulic, it has both. So this inlet and output valve is used to actually to send to intake the oxygen and fuel. Okay, and when it's compressed, when the gas is when the fuel is compressed with air, then it will do for the next combustion. Okay. So after combustion, then you have the O2, then it will actually go up through the exhaust valve here. Okay, so spark plug is in each of the chamber. So if you have a 4-stroke engine, then you have 4 spark plug at each chambers. Okay, so all of this, if you see here, is that you have a hydraulic system. Hydraulic system basically, if you see here, is an injector is injecting oil into this chamber, and you have the oxygen intake sensor that is detecting the level of oxygen to the chamber over here. So you have and all cars right now, normally they have the ECU. ECU is the electronic control unit. Okay, it's going to control the sensor, okay, detect the level of oxygen, detect the temperature at the chamber, okay, detect the speed, okay, you have the speed sensor, you detect the wheel, the crank motion, what is the speed of it. Okay, speed sensor basically converting from the RPM to the speed, kilometer per hour. Okay, so all of this is important, ECU, and most of the cars nowadays have the electronic control unit over here. Okay, so pressure regulator is something that to control the pressure when you do the combustion. So pressure is important to be read there. So this is important also in a engine control system. Okay, so what your friend explained just now is basically we look at this diagram down here. Okay, down here you can see that we have 4 engine block. So you have 1, 2, 3, 4. So we call this as a 4-stroke engine. Okay, 4-stroke engine. So basically you have 4 cylinders. Okay, and you have here is the crank and slider. Okay, so we have 1, 2, 3, 4, 5. And each of the crank, you see that each of the crank is not the same. Okay, only 1 and 4 is at the same position, and 2 and 3 is at the same position. And all of this crank is connected through a rod. Okay, so that's where we call it as the crankshaft. Okay, crankshaft is the rod connecting all of the crank. Okay, so when this crankshaft rotate, what happens is that it's going to move the piston up and down accordingly. So 1 and 4 will be balancing out with 2 and 3, so that, you know, when we drive the car need to balance. If it's not balanced, then the power will not be smooth. So, and on top of this, each cylinder, you have the valve. Okay, inlet valve and output valve just now. And you have here the cam and follower. So you have cam and follower on top of here. Okay, cam and follower. And this cam, see this part here, this rod here, okay, is connecting all of the cam. Connecting to all of the cam, so it's called as a camshaft. Okay, camshaft. When you talk about shaft ni macam rod lah rod. Satu rod panjang, tapi ada cam on top. So it's one interlink. So that camshaft is connected to a timing belt. Okay, so this timing belt over here and another timing belt on the right there. So all is linked using a timing belt to the crankshaft. So basically, this crankshaft will be connected to the wheel. Okay, to the wheel. So this is the mechanism of a combustion engine. Okay, so of course it's not directly to the wheel. Ada lagi different component inside. Okay, but the idea is that, okay, so we call this as an inline engine. Okay, if you see here example, we have a engine that is V type. Okay, so we have example V6 engine or V8 engine. So V6 and V8 engine is more compact, but it's much more difficult to build because of the how it's designed. So it need to be balanced out. So you can watch the video that I showed to you in Telegram about V6 engine versus inline engine. Right. So we go to the 4-bar chain. Okay, next. So 4-bar chain is basically underneath here is a fixed part. Fixed part. Fix. Up to you. Fix a wall, fix to a component, a vehicle, and so on. So the linkage, this is the joint. Joint means that at each joint, you are going to link, you are connected to a link here. So basically, what happens is that, imagine that if this is fixed, what happens if you move this link number 1 in this rotation? Okay, so what happens is that this link will move to the right side. This one also will move. So all of it will be moving. Okay, so this is, we call it as a double level mechanism. So these 2 points, okay, and this point will not be static. It's going to move accordingly. Okay, second one is that lever crank mechanism. Okay, lever crank mechanism is basically similar like what you see in the crank and slider mechanism. Okay, means that you have the crank over here. Okay, so this part is connected to a wheel and it's going to rotate accordingly. So it's going to rotate full. So based on that, this part will actually move. Okay, rotate this way and this way. Okay, so if you see in the crank and slider mechanism in a combustion engine, why it can actually move in a linear instead of a rotation? Because it has you have the chamber. You have basically the chamber. The chamber is the guide. So it's going to actually make sure that the piston, if you imagine that this is a piston, the piston is just going to move in X direction only. Okay, because of the chamber here. Okay, right? So if you don't have the chamber, the guidance system, we call this as the guiding system, then it's going to move in the rotation. Okay, so we can upgrade this lever crank mechanism to slider crank mechanism. For example, in a engine block. Next is the double crank mechanism. So double crank mechanism, basically at both sides here you have the crank type. Okay, so this one can rotate this way and this one can do a rotation at a fixed value. So it can actually rotate at this fixed value. Okay, so these are types of 4-bar wheel, 4-bar chain. So another type of 4-bar chain is being used in mechanisms such as in a film, advanced in film in cinema camera. So you can actually connect this at a fixed value and with a different distance here. Okay, by doing that is that you can, if you put a force at this end at point 1, you can actually pick up the point. Okay, macam you tahu old cinema okay, yang jenis yang disc tu kan. So you can pick it up and put it down. So this is the mechanism that is used. And also 4-bar mechanism also can be used to toggle position. Okay, example of toggle position is that, example truck body. Imagine that you are the truck here. Okay, truck, you have the wheel here. So this is truck body. So it's fixed. This is fixed to the body. The body is not the head lah, the head of the body. So what you want to do is that tailgate, you want to move it up and down. Okay, so you connect a 4-bar chain like this. So you can actually, this is a fixed point, then this one can be moved up and down. Okay, in linear position lah basically. Okay. And this one is another type of connecting rod and slider. Okay, so you have a fixed point here and another fixed point, but you have a guide. The slider is being guided, similar like the engine block just now. Okay, like the piston. So this piston can only move in this direction because of the guide here. Okay, the guide. So when this rotate, when you put some force here, this piston can move left and right. Okay, so that is the concept. Okay, and we have gone through this one, the crank and slider mechanism. Basically, you have watched it in the video. So the sequence is basically, we have the initial sequence at this position A. It's in line, everything. And then what happened is that when you give a force here, this piston will start to move to the left side. Okay, until it have full rotation until this part, then it will reach this initial position. So this is where you call it as the intake stroke. Okay, just now, because you have the combustion is like this right now, okay? So this one is the intake valve. And then continue again, continue until here, then you have this one will be the exhaust part. Okay, exhaust stroke. Okay, so imagine that, just imagine that with the video that you watch. Okay, so okay, this one we have gone through, and this one is example of V8 engine. Okay, V8 engine whereby the engine is, the crank is in the middle like this, and it's being connected to 2 slider. Okay, so the design is a bit different from the inline engine just now. Okay, so you can go through example of other linkages, can crusher and so on. So this one is just to try to understand how does it work. Okay, which part is the fixed part, which part is the moving part. Okay, so try to go through that. Okay, ada lots of example that I give to you, so try to go through the example of stair climbing mechanism. How can this mechanism actually move up? So try to imagine how it can move up. This one is example of a box that can turn itself out. So for example, apa panggil musical box. Bila you buka dia, bila you buka penutup dia, and then it can move up. So that one is the one of the concept, and one application that they use linkages is the airplane landing gear mechanism. Okay, so in my slide, I have shown you lots of application for you to imagine where this type of linkages are used, okay, in daily life. So I think you are familiar with the exercise machine. So ni example of rowing type mechanism. Okay, rowing type. Or you have the exercise type like this. Okay. And this one is example of I think this is example of where it's actually retracted. You have a table, okay, level on the ground floor, and imagine that if you put somewhere here a motor, connect this part, okay, imagine that at this part you connect to a motor, okay, so you move this part will move out, okay, so it will go up and go to the maximum position. So where can you actually find this type of mechanism? What do you think? Pernah nampak tak this type of mechanism anywhere? Guys? No. Not exactly the same type lah, but imagine kat mana pernah tengok? Cari sendiri tak boleh bagi answer semua. Lori. Yes, lori Okay, lori tu a good answer. Okay, you want to transfer a load from up to bottom Okay, so you cannot actually solve everything, go and transfer it upward kan. So you have lorry actually have this type of mechanism, and even lift. Okay, have this type of mechanism. Kalau in a factory, they have between pavement because it's not on the same level. So they have this type of mechanism, lift Okay, another example of linkages in prosthetic knee mechanism. So you see, in order for us human to actually develop prosthetic knee, it's actually very complicated. It's not that easy to actually make it work as a human, biological human leg. So Allah tu memang jadikan our body ni memang complicated sebenarnya. Okay, next. Oh, baru second part Okay, cam, I go to very fast because you have seen the cam in the engine part. So cam and follower is basically you have this is the cam. Okay, follower is basically it will follow the cam motion. So the cam is going to move in rotation. Okay, where you can see this cam and follower is the letter machine and sewing machine Kalau sewing machine pun ada ini. So if you see here is that cam is a body which rotate or oscillate. So it's going to rotate. And in doing so, impart reciprocating motion to second body, which is follow flow. So it's going to, when it rotate, the follower will move up and down. Okay. So there are different types of cam. You can see that the cam type, you have the point type, knife type, roller type. You can read through that sliding, flat, and mushroom type. Okay. And what I want to explain is the graph that is going to move, give based on the motion. So imagine that you have this type of cam which is offset, not in the center here, but offset. So when it rotates, it's going to give the follower movement this graph. So it's going to give this motion. This maximum motion will be at this part. So it will give this maximum motion. So you can see that is the maximum motion here. Okay, and the lowest motion will be at this part. Okay, so it will give this type of motion. And based on that concept, that's the reason why, based on different cam shape, you can actually control the displacement of the follower, this follower. Okay, so if you have the heart shape type like this, heart shape type, so you can actually design the motion of the follower to have this type of displacement. Okay, it has a constant rate, moving up and moving down, uniform speed. And another type of a follower that is normally used in an engine is, which is in the control valve of the engine, on top to open the valve and close, is the pear shape. Okay, so pear shape ni dia macam ni. So what happens is that when you have this type of motion, at this part is where you have the combustion happen. Okay, you open a very small part at that time to actually combust to do a combustion at that time. So that is where the engine will able to do a combustion. Okay, so it will rise and fall symmetrically, a very small part at where the valve will open. Okay, so other than that, the valve will close. So the next one is gear. So gear also I have covered through yesterday. So we have the bevel gear, worm gear over here. Okay, and this is the heliaxial. No, this is the, I think it's the heliaxial gear. Okay, so gear train. So what does it mean by gear train? Gear train is the mechanism which are widely used to transform rotation motion. So rotation to rotation. And gear train is when you have multiple gear in line. So if you have one gear and second gear, so you call it as a gear train. So this one I have shown to you yesterday. So planetary gear. Can I still? Okay, so this is example of how you can convert why a rolling cylinder is actually converted to a mesh gear. Reason why rolling cylinder has slip, and depending on the friction force between these two cylinders, so it's the best idea is to use a mesh gear. So mesh gear is where you have tooth for each part. For the gear 1 and gear 2. So A, B, you have gear, you have the tooth, so it will prevent slip. Okay, using meshing gear. And how you calculate for the gear ratio? Okay, ratio is that by using this number of teeth on B, the second gear over the first gear, then you get the ratio. So just do a quick calculation. What do you get? What do you get the ratio of the gear? Apa ratio dia? 80 bagi 4. 2 lah. Okay, lambat. Okay. Lambatnya jawab. Congak je. Okay. So, next is the gear train. Gear train, like I mentioned, if you have 2, it's also called as gear train. So, you have 3, then it also in an intermesh gear wheel. Okay, so how you can calculate this gear train is that you calculate the gear ratio is the first gear over the last gear. So you have WA over WC. So basically you can actually calculate WA over WB times WB over WC. Okay, so you get the gearing system, the ratio. And other than that, you have the compound gear train. Compound gear train means that 2 wheels are mounted on a common shaft. So you have gear B and gear C is mounted on a shaft here. So this is called as a compound gear. So you just go through how to calculate the ratio. Okay. And last one is the rotational to translation. So gear is also used for the rack and pinion as mentioned. Okay, rack and pinion. So rack and pinion is where you it's similar like the lead screw just now. So you can use the rack and pinion in mechanism to translate from rotation to translational. Okay. Another which is similar to gear, but it doesn't look like it. Gear is ratchet and pawl. Ratchet and pawl is basically used to lock a mechanism when it's holding a load. So you want to lock it at a position. So if it's gear, you cannot lock the position. So the pawl is the engaging arm. So basically this part is the arm. Ratchet is the sawtooth. It's like the gear. So let's look at the video.
This is a ratcheting PVC cutter. It's great for cutting pipe. To open up the PVC cutter, you pull it apart like this. You'll notice all these different teeth. That's the ratcheting portion of the tool. Notice that when I squeeze it, the blade only goes so far, and I release very gently with my hand until this next tooth engages. It engages and I squeeze, the blade moves a little bit farther. I release until the tool engages. I squeeze, the blade moves farther. I release, so it becomes like a kind of a pumping action on how this ratcheting tool works. So I'm going to open it up again. I'm going to stick my PVC pipe in. I call this the saddle. You always want to make sure that the blade is on top. Oh, and you also have to make sure that you release the lock here.
Yeah, I think you have this type of
I'm going to squeeze. If you have small hands, you can use 2 hands together. Notice that it only goes that far. I've closed it all the way. And I'm going to release it until the next tooth engages. Then I'm going to squeeze it again. See, it hasn't gone all the way through. I'm going to release again until the next tooth engages and squeeze again. And then it's...
So, ratchet mechanism is used to lock mechanism. So, if you want to lock a mechanism at a different level, so it's best to use this type of ratchet and fall mechanism. Okay. So, bed drive is basically, I think I have, you can go through. It's very simple, and I have explained it yesterday, most of it. So, you go through the bed drive. So, bed drive is something that you have the belting type. So type, you have the round belt type, V belt, flat belt, and also tooth belt. So common one that you use in the engine and the car is the tooth belt. Okay, tooth belt ni, if you see here, okay, the advantage of using the tooth belt or timing belt is that it prevents slip, okay, and it doesn't stretch out. So normally we use a timing belt, or you can use a V-shaped belt like this. So it can actually prevent from slippages. Okay. And additional that we use in a motorbike or bicycle is chain belt. Okay. And chain, mostly you will use it together with gearing system. Okay, gear. So that's why in a car, in a motorbike or bicycle, you have the chain drive system plus the gearing. Okay, for the bike. Okay, so just go through this one. And for the belt and drive system, as I mentioned before, okay, you can control it in the same direction. But if you want to cross the direction or reverse driving, you can actually cross the belting like this. So it will reverse the direction of the B and A. Okay, and last one before we end is on the bearing. Okay, ball bearing. So ball screw animation is similar like lead screw just now. But it has a ball bearing inside, so it's more less friction basically. So because most of the ball bearings are frictionless. Okay, they are designed to be frictionless. So you can just watch the video. I will skip that. Okay, and relatively it's used to result. So if you see here is that for other types of system without bearings, you have lots of friction. So you want to use a bearing so that it will be less friction, okay, and reduce wear and tear lah, basically. Okay. Okay, and go through this one. There are types of bearings, and you can go through deep groove type, deep groove angular contact type. So just read through that. Okay. So that will be the end of the chapter 6. So I have update in the ULearn individual. Okay, not the group discussion. Individual is individual task. Okay, this task from slide 68. Okay, I'm giving you this different type of mechanism, different type of application. So 69 until 77. Okay, so go through the video. Okay, and after that, please submit the task in ULearn. Okay, I have opened a submission task. Deadline will be next, not Friday, Sunday, next Sunday. Sorry, I have set it next Sunday, which is on 5 December. So it's an individual task. Read through the instruction. So you need to scan after you have list out all of the mechanism. No need to draw out the diagram. Just if possible, copy, cut and paste it into Word and then list out what are the mechanism. Not list, label it. Okay. So you have this one like this. So label it. What are the mechanism you have? So you have the cam and crank and slider mechanism. You have the cam and follow mechanism. So for this, what are the mechanism inside? So label it. Okay, label it. Cut and paste into Word and submit. Okay, in ULearn. Okay, and last one. Sorry, I'm taking a bit of your time. So last one is that for this one, last application is that by entering the apps that I showed to you yesterday, so the 3D engineering apps, okay, go and watch the one which is sewing machine application. So sewing machine application, let me just share that. Share content. Share. Mana share? Share screen. Okay, I'm going to share. Okay. Okay, so go to the 3D engineering mechanism. Okay, and then download. Click on the you need to go through one of it as oh yeah, this one, sewing machine. So open that. So look at the mechanism from this sewing machine. Find out what are the mechanism that you have in the sewing machine. Okay, so maybe you want to see it only the mechanism. So you can try to zoom in. Okay, what mechanism that is there in the sewing machine?
Rising, but the
Okay,
main action is
so
happening down under
that's
the
all for
material
today
where the shuttle
class.
hook
So
drags the needle loop right
try to
around so
answer
that it
that
locks
and
around the bobbin
upload
thread.
it.
The needle is pulling upwards and then tightens the red thread. It pulls the stitch tight.
Okay, so that'll be all. So complete the assignment, submit it in the ULearn, and then also complete this one for the sewing machine. List out. Okay, list out what are the applications. So I would suggest, okay, screenshot that mechanism, put it in Word and label it. Where are all of the mechanism? Okay, don't just list out like this, but label it. Okay, so you can screenshot the sewing machine inside the application, and then you label it accordingly. Okay, so and then after that, please remember to submit the feedback form. I have opened it. You can submit it. You don't need to wait until you submit the assignment. Okay, you can just complete it by today. Okay, so that will be all from me. Any question? Any question? If no, okay. If no, that's all from me. Sorry, I took 3 minutes of your time. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.